So we're going to end up with talking about two new additions that were made to Java version 7 that relate to exceptions, and then just summing up kind of a general overview of what we talked about with exceptions. So the first new addition to Java 7, which is really great, is something called try with resources. So the old method, if you wanted to use certain input and output classes, is that you have to declare the class, declare the object of that class outside of the try catch block, and you usually initialize it to null. Then inside of the try block, you use it. Then you have a catch clause related to that kind of exception for that type of IO. And then inside of finally block, you want to make sure that you close the resource, but first you have to make sure it's not null, right? Because there could have been an exception generated when you tried to create the object. So if that happened, the object would still be null. So first you have to make sure it's not null before you close it. Because of course, if it was null, you can't invoke any method on it, including close. So this is kind of a cumbersome setup for doing something that's pretty common, like input and output. And another complication is that some type of objects actually can generate an exception from the close statement, which means this statement can also generate an exception. And then what you have to do is kind of put this whole finally block, you have to nest inside of that another try catch finally. Kind of gets very confusing. So this is sort of the old approach that we're used to using. And of course, you saw that when we did our number file output example, where we declared the printWriter object and initialized it to null. Then we instantiated it inside the try, and then inside the finally we made sure it wasn't null before closing it. So we've used this, and this works fine, but it's not the best setup. So Java came up with a new setup that you can now use as long as you're running Java 7 or later. And it's called try with resources. And essentially how it works is that you have parentheses after your try block, your try word rather. And inside of those parentheses, you declare and initialize any resources that you want to use inside the try block. Now what this means is that you no longer have to close them yourself inside of the finally. They will automatically be closed for you. So you no longer have to manually close them. Pretty great. So no matter how your try block exits, whether an exception was thrown or no exception was thrown, whether an exception was thrown and caught or thrown and propagated, it doesn't matter. It doesn't matter how the try block gets resolved. That resource that's declared inside the try with resources part will always be closed. So it's the same as if you were to put it in your own finally block. It's just that you don't have to actually write the code to do it. So it's pretty great. You can declare one resource inside of a try with resources statement, or you can declare multiple. You would just separate them with a semicolon. You can declare any object in there as long as it implements the auto-closable interface. So this is an interface in the Java standard library. Essentially, any of the IO classes you're going to want to use are going to implement this interface, but you can always check the API to be sure. So for example, here is the printWriter class. And you can see that printWriter implements auto-closable, so we're good there. If we look at, for example, the string class, string does not implement auto-closable, so we could not declare and initialize a string inside of a try with resources block, which we wouldn't want to do anyways. But if you ever want to know if the kind of object that you want to use can be put there, you just check the API and make sure it implements auto-closable. Okay, so let's take a look at converting this file that we use, the number file output. I'm going to save it as number file output 2, and we'll use the try with resources. So again, what you do is you put parentheses, and then you just declare and initialize all of your resources inside those parentheses. So I'm going to say my printWriter output writer gets null, or actually, don't need to start with that. I'm going to start with my file writer gets a new file writer with my output file. Then my buffered writer gets a new buffered writer, sending in my file writer. And my printWriter output writer gets a new print writer, sending in my buffered writer. So I can get rid of all these other lines. Don't need to declare it outside the try block anymore. And the really nice part, I can get rid of my finally block altogether. I don't need to close it anymore because I'm guaranteed that it will be closed. Okay, so this is a pretty great improvement. Again, anytime you want to use any of these input-output resources that normally you'd be responsible for closing, you can put them inside of a try, parentheses next to the try, And this is called a try with resources, and then you're guaranteed that these resources will be closed in what would be parallel to a finally block. Now again, if we wanted to put string in here like this, we couldn't. So if we tried to do that and compile, you'll see we get a compiler error because it's that type of resource is not compatible with try with resources, because again, string does not implement auto closable. So you can't put anything inside there, just things that implement that auto closable interface defined in Java. And again, that's going to be most of your input output classes. The other really great update in Java 7 is the ability to handle multiple exceptions within a single catch block. So a lot of times you have the exact same code inside of 3 or 4 catch boxes. Like for example, maybe all you're doing is just printing the stack trace. Well, in the old approach, you had to have catch exception type A and then print the stack trace, and then catch exception type B and print the stack trace, catch exception type C and print the stack trace. So you ended up having a lot of catch blocks that all did the same thing as each other, but you need to have them in order to represent all the different kinds of errors that might happen. Well, in Java 7, we have a better way to do that. You can now have just a single catch block, but you can list multiple types of exceptions that could be catched by that single block. Now, you only want to use this approach if all of your exceptions will be handled in the same way. So if you have 2 exception types that are handled a little bit differently, you'd want to use the old approach. But if all your exceptions are going to be handled in exactly the same way, then this is a great approach to use. And here's what it looks like. The same setup. The setup is the same with the try and multiple catch blocks. But let's say, for example, we had exception A and exception B, and we're doing the same thing to handle those 2 kinds of exceptions. Well, now we can just list them both separated by the single vertical bar. And this says this catch block can handle exception A exceptions or exception B exceptions. And this allows us to handle them in a single catch block. So again, we'd only do this if we were handling these 2 exceptions in exactly the same way. So if, for example, we had exception type C and we're doing something a little different for that kind of exception, we would still put that one in its own catch block. But if exception A and B are being handled in the exact same way, we can put them in a single catch block and again separate them with the vertical bar. Note that there's only one parameter name, so it's not exception A EX bar exception B EX, but it's exception A bar exception B and then a single parameter name EX. Okay, so those are 2 really great updates in Java 7. I encourage you to use both of them. They were designed to kind of make things easier, so and I think they do. They're good updates. So let's bring this all back together and kind of do a quick summary of exceptions. So here's the bottom line for kind of handling exceptions. When an exception is thrown, what we do is we look for the first matching block, the first matching catch block that matches that type of exception, and we start with the current method. So we look where we are, we stop whatever we're doing in the try block, jump down and start checking all the catches. If we find a catch that matches the type of exception that was thrown, we execute that catch, then we execute the finally, and then we're done with the try catch finally, and we just move on to executing the first line after that whole try catch block. Remember that we never go back up into the try. That's kind of a common mistake. It's not like we handle the exception and then we jump back up and pick up where we left off. Nope. Once we exit that try block, we're done. We never go back. Now, if on the other hand, you do not find a match for the type of exception in the current method, so you stop the try code, you start checking the catch blocks, but let's say none of them are a match, then what we do is we execute whatever is in the finally, and then we just leave this method. We're done with this method, and we go up to whatever method invoked us, so whatever that previous invoking method was, we turn to whatever line it was that invoked this current method. So kind of wherever that previous method was put on pause, that's where we return. And then we just repeat this step, but using that method. So again, if that method was inside of a try block, we are done with that try block inside the previous method. We jump down and start checking the catches. We again never will go back up and execute code later on in the try block. We never jump back up. So this is kind of the bottom line approach for handling exceptions. And then this is a summary about our exceptions. So Java's exceptions can be checked or unchecked. Checked exceptions must be handled in order to compile. So you are not allowed to ignore checked exceptions. You have two options for handling them. You can either catch them in the current method, or you can propagate them and deal with them somewhere else. If you propagate them, you must declare that that's happening by putting a throws clause in the method header. So these two things go together. If you're going to propagate them, you have to tell the compiler that by using throws. Then we have unchecked exceptions. There's basically two ways to use these. One is just design your code to avoid them. So these are things like array index out of bounds exceptions and null pointer exceptions. These aren't exceptions we use try catches for. We just design our code carefully to avoid them being thrown. Okay? But we can also sometimes use unchecked exceptions to our advantage. So for example, when we're reading in numeric data, catching it's sort of a expected event that a user might type in bad data. So we can use this type of unchecked exception to kind of handle that situation. So sometimes we can use unchecked exceptions to our advantage, like when we're reading in numeric data. Now, the compiler does not force us to handle unchecked exceptions, but we can choose to handle them. Again, like in this case here, we can choose to use them to catch the case of the user giving us bad input. And if we decide to handle them, we can either catch them in place or we can propagate them. So this would be similar to how a checked exception is handled. It's just that we're choosing to do it rather than the compiler forcing us to do it. Now, you can also write your own exception classes to represent your own error conditions. You write your exception class that extends exception, or you can also extend runtime exception if you want your exception to be unchecked. Then once you write the class, you actually have to throw the exception because, of course, you're writing your own class to describe this error situation. You're the only one who knows where that error situation happens, so you have to actually throw the exception as well as writing the class that represents the exception. Then once you throw it, you either catch it or handle it where it is or propagate it somewhere else. A couple of tips for using exceptions. Don't replace simple conditionals with exceptions. So we can go crazy with using exception handling, but don't go overboard. Sometimes a simple conditional is all you need, like checking if a list is empty or if a number is negative. Those kind of situations probably don't require using exceptions. Even though I might have used some of them in the examples for this series of videos, typically a lot of simple things like that can just be handled with conditionals. So it's finding a balance there between using conditionals and using exception handling. You want to put some thought into when you're using which. Try to think about putting your full kind of tasks inside of try blocks. So obviously you could write your code where every single statement goes in its own try catch block, but that would not be very readable code. And it also kind of wouldn't satisfy the main idea of why we use exceptions, is to sort of group together all of that exception code in one place. So try not to put kind of single lines inside of those blocks, but instead think about putting full tasks, kind of like this is a group of 10 lines of code that represents a single task, a single job, and all of this is going to go inside the try block, representing good execution flow if nothing goes wrong. You should throw and catch specific exceptions, so do not have a catch block that catches the generic exception type. This is very bad design. It's essentially saying, hey, something could go wrong here. It's like a catch-all. I'm not going to tell you what the kind of errors that could happen are, but anything could happen and I'm handling it. It's not a good design. So don't do that. You want to think about the specific kind of errors that could happen, and you want to write specific catch blocks for those specific errors. And then you want to put some thought into handling exceptions in the right place. So if it makes sense to handle an exception in the current method, then handle it there. But if it makes sense to propagate it and kind of gather up common exceptions from multiple classes and handle them up in a higher method, then do that. And this is also kind of subjective, like a lot of other things. Two people might look at the same problem and approach it differently, and that's okay. The idea is just to put some thought into it and make sure that you can explain the choices that you've made for handling that exception. So one last slide here, exceptions. Why do we bother with all this? Well, there are several advantages to using exceptions. The first is that, again, it separates that error handling code from the normal execution code. So it allows us to say, hey, everything in this try block is what will happen if everything goes well. And then separate from that, here's a group of statements that represents how we're going to handle things if things don't go well. So it separates logically kind of the good execution from the erroneous execution, which is nice to kind of separate those cases. It also allows us to propagate errors up the call stack. So again, if it makes more sense to handle an exception somewhere else, to handle an error somewhere else, we can do that with exception handling. We can't really do that with conditionals, right? Conditionals kind of only work where they're written. But exception handling does allow us to kind of pass these situations or these conditions up higher in the call stack. And then it allows us to group and categorize our errors. So we can use the rich hierarchy of Java provided exceptions, or we can write our own exceptions. And this allows us to kind of group together exceptions that are similar to each other. It allows us to describe our exceptions by their title, by their name. So it allows us to kind of describe, categorize, and group together all of these error situations. So exceptions are really great. You should use them in the kind of instances we've talked about. And again, you should be familiar with both the Java provided exceptions as well as how you'd write your own exception classes.